Imagine a world where computers don't just assist in research, they actually invent materials that have never existed before, solving problems that have stumped scientists for centuries. Picture a future where AI becomes the architect of the fundamental elements of our physical world, pushing the boundaries of what humanity can create. Well, stop imagining, because that world has arrived. Researchers at Berkeley Labs and Google DeepMind have developed an AI that has designed a completely new superconductor material. This isn't theoretical hype. It's a seismic shift that could redefine how we build quantum computers, revolutionize global energy systems, and open doors to future technologies we haven't even conceptualized yet. This breakthrough represents the convergence of artificial intelligence, quantum mechanics, and material science into a new era of discovery. It's the birth of a new design paradigm, where AI acts as a co-creator alongside human ingenuity. Before we get into the mind-blowing details, make sure to hit that subscribe button, give this video a like, and turn on the notification bell so you never miss an update on the next technological leap. Sharing these stories sparks curiosity and might just inspire the next big idea. So how did this come to life? Let's rewind and set the stage for this unprecedented achievement. Superconductors are extraordinary materials that can conduct electricity with absolutely zero resistance. That means no energy gets wasted, no excess heat is generated, and electricity flows with perfect efficiency. But here's the catch. Most superconductors only perform this magic trick at temperatures near absolute zero, colder than the vacuum of space. Keeping materials that cold requires expensive and complex cooling systems, making superconductors impractical for mainstream use. The implications of finding a superconductor that works at room temperature are staggering. It could completely transform energy consumption, transportation, and computing. It would redefine the limitations of energy efficiency across nearly every industry. For decades, scientists have been chasing the holy grail of materials science, a room temperature superconductor. The potential impact is colossal, revolutionizing everything from national power grids to quantum computers. But designing new materials at the atomic scale is a Herculean task. There are trillions of possible atomic arrangements, and testing each one in a laboratory would take multiple lifetimes. Traditional trial and error approaches simply aren't viable. Researchers needed a way to intelligently explore this vast landscape of possibilities with speed, precision, and creativity beyond human capacity. That's where AI enters the scene as a game changer. The team at Berkeley Lab, in collaboration with Google DeepMind, developed a groundbreaking AI-powered quantum chemistry platform. Unlike traditional models that rely on approximations, this AI simulates atomic interactions with quantum-level precision. It learns the complex dance of electrons and atoms, predicting how various atomic combinations will behave under different conditions. This level of simulation accuracy enables the AI to uncover material properties that would be invisible to human researchers or conventional computational methods. It's like equipping scientists with a microscope that peers into alternate dimensions of material possibilities. Think of it as a hyper-intelligent architect, capable of designing entirely new materials from the ground up, atom by atom, while considering billions of variables simultaneously. The AI doesn't just generate random configurations, it understands the underlying physics, allowing it to target specific material properties and optimize for them in ways that human intuition cannot. It's an iterative creative process, where AI explores, learns, refines, and perfects designs with a level of thoroughness and speed that no human team could match. Using cutting-edge material simulation algorithms, the AI scoured through astronomical possibilities to predict stable atomic structures that human researchers had never considered. These patterns were too complex for conventional computational methods to even recognize. This is quantum chemistry amplified beyond human cognitive limits, allowing the AI to navigate multidimensional design spaces that would take human scientists decades to chart. The AI's ability to model and evaluate millions of atomic arrangements in a fraction of the time accelerates the innovation cycle exponentially. One of the pivotal breakthroughs in this project was the integration of reinforcement learning. The AI was designed to reward itself for discovering atomic configurations that displayed superconductive properties at higher temperatures. Over millions, yes, millions of iterations, the AI evolved its designs, continually refining and optimizing until it unveiled materials that defied long-standing assumptions in physics. This evolutionary process mirrors natural selection, but at a vastly accelerated pace, condensing centuries of research into mere months. Imagine compressing the entire scientific journey of superconductivity discovery into a single AI-driven sprint. The result? A material with superconductive capabilities that push the boundaries of what current technology can achieve. While it's still in the experimental phase, initial lab tests indicate performance metrics that surpass existing superconductors. This could be the stepping stone toward practical, everyday superconductivity, unlocking a future where superconductors become an integral part of our daily lives, from consumer electronics to national infrastructure. The ripple effect on industries like computing, energy, transportation, and healthcare would be monumental. But here's where things get even more fascinating. This AI's capabilities aren't confined to superconductors. Its architecture is adaptable to discover materials for high-capacity batteries, ultra-efficient solar panels, advanced biomaterials for medical implants, and more. We're witnessing the dawn of an AI-driven materials discovery revolution. Industries across the board, energy, healthcare, aerospace, and beyond, stand to benefit from this paradigm shift, as AI accelerates innovation cycles and enables breakthroughs that were once deemed impossible. It's a new chapter where AI-driven experimentation becomes the backbone of scientific progress. Let's talk impact. Superconductors have the potential to overhaul global power grids by eliminating energy loss during transmission. Imagine a world where cities operate on power with near zero waste, dramatically reducing carbon footprints and slashing energy costs. Quantum computers, which rely on superconducting qubits, could achieve unprecedented stability and processing power, making today's most advanced machines look primitive by comparison. High-speed maglev trains could become more affordable and widespread, revolutionizing transportation infrastructure. Medical imaging devices like MRIs could deliver sharper, faster results at a fraction of current costs, democratizing access to advanced healthcare technologies. The implications are not just technological but economic, societal, and environmental, offering a pathway to a more sustainable and connected future. And it's not just about speeding up the process, it's about redefining human creativity. AI can venture into realms of possibility that human intuition alone could never reach. It's like giving humanity an infinite sandbox where the laws of physics become flexible building blocks, not obstacles. The synergy between human ingenuity and AI's computational power opens doors to innovation we haven't even thought to knock on. With AI as a creative partner, the pace and scope of invention expand exponentially. But here's a question for you. Do you believe AI should be officially recognized as an inventor? Let me know in the comments below. And if you're loving this deep dive, hit like, comment, and ensure you've turned on notifications so you're always in the loop. The future's moving fast and you don't want to miss a thing. Of course, challenges remain. Theoretical designs need to be physically synthesized in labs. These materials must undergo rigorous testing under varied environmental conditions, and the path from discovery to scalable industrial application is no small feat. Manufacturing processes must be adapted to accommodate these novel materials, and economic considerations will play a crucial role in determining how quickly these innovations reach the market. But thanks to this AI's capabilities, what once took decades can now be achieved in months or even weeks. This acceleration compresses R&D timelines and could redefine how industries approach innovation cycles. Google DeepMind's involvement is crucial here. Leveraging their expertise from AI milestones like AlphaGo, they applied similar reinforcement learning strategies to tackle the infinitely more complex field of materials science. This cross-disciplinary approach is nothing short of revolutionary. It showcases how techniques honed in one domain, like mastering board games, can be adapted to solve some of the most challenging scientific problems of our time. Their collaboration with Berkeley Labs amplifies the impact, combining AI mastery with experimental validation in a way that fast-tracks discovery. Berkeley Labs, renowned for their pioneering work in quantum materials and nanotechnology, offered the perfect ecosystem for this breakthrough. Their collaboration with DeepMind exemplifies the power of partnerships that bridge academic research and cutting-edge AI development. Together, they've demonstrated that AI can transcend its role as an analytical tool. It can become a creator, architecting the very building blocks of future technologies. This shift transforms how we think about invention itself. What we're witnessing is the birth of a new scientific era, AI-accelerated materials discovery, and this is merely the first chapter. As AI models become more sophisticated and datasets grow richer, we can expect even more groundbreaking discoveries in shorter time frames, fundamentally altering the landscape of scientific research. The iterative loop of AI-led design and human-guided experimentation will become the gold standard for future innovations. In the coming years, this AI-driven approach could lead to materials with self-healing properties, adaptive semiconductors that modify their behavior in real time, and even programmable matter that changes its structure based on environmental stimuli. Imagine buildings that repair themselves, smartphones that evolve new features overnight, and vehicles that adapt their materials to enhance safety on the fly. The frontier is wide open. This isn't a distant sci-fi dream, it's a tangible, near-future reality powered by AI. But let's bring it back to you and me. This isn't just an academic or industrial leap, it's a transformation that will ripple into our daily lives. Faster, more energy-efficient devices, sustainable transportation, smarter medical technologies, all brought closer to reality because of AI's ability to outthink, outdesign, and outcreate traditional methods. It will redefine how we interact with technology on a personal level, making futuristic concepts accessible and practical for everyday use. From the smartphones in our pockets to the infrastructure of entire cities, AI-driven material innovations will touch every facet of modern life. So the next time you hear someone say AI is limited to chatbots or image filters, tell them about this moment. Tell them how AI designed a superconductor material that could change the course of technological evolution. Share this story, because it's a glimpse into a future where AI and human ingenuity co-create the next wave of civilization's most transformative tools. This is the dawn of a new creative partnership, where possibilities are only limited by imagination. This AI created a new superconductor material, and that's just the beginning. Before you go, hit subscribe, like, share, and turn on notifications. We're here to break the silence around future tech, one myth at a time. This is Tech Mythos.